Lenz's law is an important law related to electromagnetic induction because it is helpful in predicting the direction of induced current, whether the induced current flows in clockwise direction or anti-clockwise direction. That can be understood based on Lenz's law. Even the polarity of the induced EMF, like a conductor has a changing magnetic flux, so which end of the conductor develop positive polarity and which end develop negative polarity. A polarity of the induced EMF can be predicted with the help of Lenz's law. The direction of the induced current and hence the polarity of the induced EMF that can be predicted with the help of Lenz's law. And this law is framed based on law of conservation of energy, meaning energy cannot be created, only it can be transferred from one form to another form. That means if energy is produced in one region, produced means energy is formed in one region, somewhere else energy has to be lost to compensate that. Energy cannot be totally like newly produced. Without having any other region, energy is lost or work is done. Without that, energy cannot be created. Like energy formed in one region must be leading to a corresponding loss in some other region. Without any work done or without our energy loss in one region, energy cannot be formed in another region. It can be transferred to one form to another form. Mechanical energy can be converted to electrical. That means work done, the person doing work, energy will be lost. That can be leading to another, the energy is created or formed. But without any loss or without any work done in any other part, energy cannot be formed in a different part. That's meaning of law of conservation of energy. So the statement will be giving a way to predict the direction of induced current or polarity of the induced EMF. So that's the way the statement starts with. The law states like that the direction of the induced current or the polarity of the induced EMF is in such a way it opposes the change in magnetic flux which produces it. The direction of induced current or the polarity of the induced EMF is such that it opposes the change in magnetic flux which produces the induced EMF. Now it is important to understand the induced current is not opposing the magnetic flux. It is opposing the change in magnetic flux. Meaning, if the existing magnetic flux is increasing, to oppose the increase in magnetic flux, the induced current will produce a magnetic flux in the opposite direction of the increasing magnetic flux. If there is an increase in the magnetic flux, the induced current must produce a magnetic flux that is opposite to the direction of the increasing magnetic flux. So if the magnetic field lines increase from 5 to 10, there's an increase in the magnetic flux. So the induced current should produce magnetic field lines in the opposite direction of the increasing magnetic flux. Here it is in the opposite direction of the existing magnetic flux also. Now if the magnetic flux linked with the circuit is decreasing, the induced current must be flowing in such a way the induced magnetic flux is in the same direction of the decreasing magnetic flux. Here the induced magnetic flux is produced in the same direction of the existing magnetic flux. That's why it was told in the beginning. The induced flux is not always in the opposite direction of the existing magnetic flux. It just opposes the change in magnetic flux. An increase is opposed by producing magnetic flux in the opposite direction. A decrease of flux is opposed. A decrease can be opposed if the flux is produced in the same direction of the decreasing magnetic flux. If the flux lines decrease from 10 lines to 5 lines, to oppose the decrease, the induced current must be producing flux in the same direction of the existing flux, so that it is tried to come back to 10 lines itself. 10 trying to become 5, the induced current add up in the same direction of existing flux, trying to make it back to 10. That is basically the meaning of Lenz's law. Now, with an example, we can understand how it predicts the direction of the induced current and how it satisfies the law of conservation of energy. Imagine we have a coil. A magnet is approaching the coil. It's moving towards a coil. Let the left side of the magnet be north and right south. The field lines of the magnet comes out of north pole. As the coil approach the magnet, or the magnet approach the coil, the magnetic flux through the coil start increasing. It was less in the beginning. Now as it approached the coil, or the magnet approached the coil, the flux through the coil start increasing. According to Lenz's law, if there is an increase in the magnetic flux, the induced current flows in such a way, induced magnetic flux is opposite to the direction of the increasing magnetic flux. That means the induced magnetic flux has to be in the opposite direction, towards right, as the existing or the increasing magnetic flux is towards left. So the coil must produce a magnetic flux in the opposite direction. If the magnetic field lines come out from a system that act like a north pole, for this right face of the coil to act like a north pole, the current must be flowing in the anti-clockwise direction. That can be understood from the arrow mark for the N. The current will be as per the direction of the arrow mark of the N. Since this N is upward, this current is also upward this side. Here N is downward, the current is also downward. Or indirectly, north pole always lead to current in anti-clockwise direction. South pole always lead to current in clockwise direction. So this is the way how you can predict the direction of current using Lenz's law. Then we will see how this is according to Lenz's law is according to law of conservation of energy. When the north pole is approaching the coil, according to Lenz's law, as the magnetic flux through the coil increases, the coil has to produce a magnetic flux in the opposite direction. So the current has to be anti-clockwise. The right face of the coil, the face near the magnet, develop a north polarity due to current in anti-clockwise direction, which is predicted with the help of Lenz's law. Since north and north are facing, the magnet now experiences a repulsion. To overcome this repulsion and to make the magnet move further towards the coil, the external agency, the person who is pushing the magnet, has to do work. So if the external agency is doing work, then only it can overcome the repulsion of the magnet, or repulsion of the north pole of the coil, which acts like the magnet. Then the magnet can further move towards the coil to produce further change in magnetic flux and induce current. If there is no work done, the magnet cannot move, it stops, no induced current is developed. This is totally according to law of conservation of energy, because the electrical energy is developed in the coil only if the external agency is doing work in pushing the magnet. So if there is no work done in pushing the magnet, there is no induced current, because the magnet won't move towards the coil. So here the generation of electrical energy is according to law of conservation. Generation means only a transfer of energy. There is no generation. The work done by the external agency in pushing the magnet, that is converted into electrical energy. Now instead of this, imagine opposite to Lenz's law. We'll try to prove the law is violated, then what will happen to the conservation of energy, whether it's satisfied or not? That means instead of this right face of the coil developing a north polarity by current in anti-clockwise direction, just imagine the right face develop a current in clockwise direction so that the right face act like a south pole. So if the right face act like a south pole, which is against Lenz's law and it's wrong, we're just trying to prove if the law is violated, law of conservation of energy also violated. So if the right face act like a south pole because of the current developed in clockwise direction we are assuming, then the magnet will be attracted, the north side will be attracted towards the south. So no need of any external work. Without external work or without any work, the coil itself attract the magnet towards it and produce what? Electrical energy. That means electrical energy is developed without any work done. That is against law of conservation of energy. So it cannot happen. So the coil can only develop current in anti-clockwise direction because it satisfies Lenz's law. The current cannot develop a clockwise direction in this particular case because that is leading to violation of law of conservation of energy. So satisfying Lenz's law indirectly means law of conservation of energy is satisfied. For the process is totally according to law of conservation of energy. So it means Lenz's law is another form of law of conservation of energy, or Lenz's law is framed so that it always satisfies the law of conservation of energy. The whole discussion is written as a statement for the reference.